What if, for just one moment, every single one of the 8 billion people on Earth jumped at the exact same time? Imagine the coordination, the anticipation, and the sheer scale of such an event, an entire planet coming together for a single, synchronized leap. From the bustling streets of Tokyo to the quiet fields of Kansas, from the icy stretches of Antarctica to the vibrant beaches of Brazil, everyone, no matter where they are, leaps together. It's the ultimate global Pogo party, a moment of unity that transcends borders, languages, and cultures. It sounds wild, almost impossible, but this is a classic thought experiment. What would actually happen if humanity united for one massive, coordinated jump? Would it be a harmless stunt, or could it have real consequences for our planet? Let's take it a step further and imagine we could somehow gather every person in one place, an area about the size of Los Angeles. The logistics would be mind-boggling, but let's suspend disbelief for a moment. The countdown begins, the excitement builds. 3, 2, 1, jump! For a split second, the entire human race is airborne. 8 billion people push off the ground, soar for a heartbeat, and then crash back down in perfect unison. The sound and energy would be unlike anything ever experienced. The energy released in that instant would be enormous. Billions of joules, all focused in one colossal moment. It's like setting off a chain reaction of synchronized stomps. But what does that really mean for the planet? Would we trigger chaos, earthquakes, or just create a tiny blip that quickly fades away? Could the Earth even notice? The energy from our landing would ripple outward, like waves spreading across a pond after a stone is thrown in. The effect would travel, but how far and how strong would it be? Would it register as a tiny tremor, barely noticeable, or could it actually shake the planet in a way we'd all feel? Let's dive into the science behind this wild scenario and find out what would really happen if we all jumped together. Spoiler alert, you probably don't need to rush out and buy an earthquake kit just yet. This isn't just a silly question, it's a fascinating way to explore the physics of mass, force, and energy on a truly global scale. It helps us understand how even our biggest actions compare to the forces of nature. So, are you ready for the ultimate experiment in human cooperation and physics? Let's jump in and see what happens. Could our jump crack the Earth's crust? It sounds like the plot of a disaster movie. Millions of people leaping at once, the ground splitting open beneath our feet. But as dramatic as that image is, it's pure fiction. The Earth is unimaginably massive, so enormous that our combined weight is less than a rounding error compared to the planet itself. It's hard to even grasp the scale. Imagine a flea jumping on the back of an elephant. The elephant doesn't notice, doesn't even flinch. That's us, compared to the Earth. Our biggest efforts are like a whisper in a hurricane. The planet weighs about 5.97 sextillion kilograms. That's a 5 with 21 zeros after it, a number so big it's almost impossible to visualize. All of humanity together, we add up to about 500 billion kilograms. That's a lot for us, but for Earth, it's barely a blip. And our force isn't concentrated in one spot, it's spread out over the entire surface of the planet. There's simply no way we could muster enough energy to cause any real damage. The Earth's crust is up to 70 kilometers thick in places, floating on a sea of molten rock. It's built to absorb forces far greater than anything we could create. Even asteroid impacts, which have shaped our planet's history, dwarf anything we could do by jumping. Those collisions release energy millions of times greater than our combined leap. Imagine dropping a single grain of sand onto a bowling ball. No cracks, no dents, not even a scratch. That's the effect we'd have on the planet. Our jump is just a tiny splash in a vast ocean of rock and magma, lost in the planet's constant churning and shifting. The planet is safe from our antics. No matter how many of us jump, the Earth remains unbothered. No matter how hard we land or how synchronized our jump, we won't break the Earth. The ground beneath us is far tougher than we imagine. The real action happens on a much smaller scale. Tiny vibrations, little ripples, barely enough to shake a glass of water. So what would we actually feel? Maybe a faint tremor, a momentary jolt, but nothing more? Let's find out what our jump would really do, beyond the myths and the movies. Spoiler alert, the planet barely notices and life goes on as usual. We won't crack the planet or send it spinning off its axis no matter how hard we try. But if every single person on Earth jumped and landed at the exact same moment, we'd definitely make a little noise, enough to turn heads and spark curiosity. Imagine 8 billion people coming down together. The impact would send seismic waves rippling through the ground, a human-made earthquake, unlike anything we've ever seen. Scientists estimate this synchronized jump would register as a magnitude 4 to 5 quake on the Richter scale, which is strong enough to be felt by many people. That's enough to rattle shelves, knock over some fragile items, and maybe even crack a few windows near the jump site. Local buildings might creak and pets would definitely be startled, but the shaking would fade quickly with distance, barely detectable a few hundred kilometers away. Most people outside the immediate area would feel nothing at all. On the other side of the world, life would go on as usual. No one would notice a thing, and the event would pass without a trace. It's like dropping a pebble in a pond. Big ripples nearby, tiny ones far away. The energy spreads out but quickly loses its punch. The main event is a localized thump, not a global disaster. The ground would tremble, but only for a moment, and only in the immediate area. The most dramatic effect? The sound, not the shake. The collective landing would create a thunderous boom, echoing across the landscape. Our jump is impressive, but in planetary terms, it's just a blip, barely a hiccup in the Earth's long history. Disaster movie fans, sorry, no chasms opening up, no toppling skyscrapers, and definitely no end-of-the-world scenarios. The Earth shrugs us off, barely noticing our collective leap, and life goes on as usual. What if, instead of landing on the ground, we all landed on a giant trampoline instead? A trampoline stores and then releases energy, launching us right back up into the air with a springy force. Imagine 8 billion people bouncing together at once. The trampoline would sag deeply, then snap back, sending us all skyward. For a brief moment, the entire planet would be human-free as we soared through the air together. We'd bounce up and down, losing a bit of energy with every single jump we made. It's a hilarious image to picture, but it shows how different materials handle energy in unique ways. The ground absorbs energy. A trampoline, on the other hand, gives it right back to you. Science can be fun, and surprisingly bouncy too. Let's talk numbers. When we jump, we push against the Earth and it pushes back. But the Earth's mass is so huge, our push barely moves it, by less than the width of an atom. As soon as we land, the Earth returns to its original position. We can't knock the planet out of orbit. Compare our jump to nature's power. Hurricanes, volcanoes, and earthquakes release energy millions of times greater. Our collective jump is a firecracker next to nature's dynamite. We've changed the planet in many ways, but when it comes to raw force, Earth is in charge. Our experiment is a reminder. We're passengers, not pilots, on this rocky spaceship. The planet's momentum is untouchable. Our jump is fun, but the Earth barely notices. Nature's forces still rule. The real spectacle? The sound. 16 billion feet landing at once would create a colossal thump, one of the loudest sounds ever made by humans. Estimated at around 200 decibels, it would be deafening and dangerous. The pressure wave could shatter windows and cause hearing damage for miles. The boom would travel outward at the speed of sound, heard as thunder hundreds of miles away. The sound would circle the globe, fading as it goes. The tremor is minor, but the sound is unforgettable. Our jump's true signature would be a thunderous, fleeting echo. Even small actions, multiplied by billions, can have loud consequences. Earplugs, anyone? So what did we learn? Our jump wouldn't crack the crust or move the planet, but it would create a local tremor and a deafening boom. It's a lesson in scale. Earth is vast and we're small. Thought experiments like this spark curiosity and help us explore the laws of physics. Silly questions can lead to real science. Imagine if everyone sneezed at once or turned on their faucets. These what-ifs make us think. Science is about asking questions, even the wild ones. Next time you jump, remember, you're pushing against an entire planet, and no matter how many join you, Earth will be just fine.